Hello. So today we are going to look at the energy harvesting record setup to trace the energy traces using the PowerCast setup. Now for this we are going to use the energy harvesting record and replay setup, which is essentially an MSP430 board with the record and replay functionality connected to our P2110B PowerCast setup, to which the antenna of the energy harvester is also connected. This antenna will be responsible for capturing the energy from the energy harvester, which will be shown further. So using this setup, we are going to record the energy traces by waving this board in front of the energy harvester in different patterns, so that we can get a numerical value for the energy traces. After that, we will record these values of the energy traces and store it in a log file, which will which we will then use to plot a trace or a graph, so that we get a visual representation of the recorded energy. So now let's look at how we proceed for the experiment. Now this is the recording part. In this, we connect the gray wire to the battery terminal of the board, and we will push the record switch. Now we will just record different patterns by moving the board around the power energy harvester, which is the black box shown. This will basically record all the different energy values, because the energy values will change as the board moves away from the energy harvester. Once this is done, we will push the record button again. So now the the contents of our energy traces will be stored. Now I have already recorded the values, so we'll look at how these values are actually put into the log file. We use a serial terminal called putty to do the logging process from our recorded values. So after setting the putty to create a log file, we just go move on to just move on to the save location, where we will be saving our log file, which will be used further for analysis. So I just create a folder called assignment 6 and save this as the location. And after that, I start a serial session. Now I'll need the COM terminal to which our board is connected. So we'll go to ports, and our board is connected on COM9. So we'll put the value COM9 in the serial line, and the speed will be kept as 9600. Once we have all our settings, that is, the baud rate is set to 9600 and our serial line is connected to COM9, we open the terminal. Now we need to push the replay button, which is the other second button on the board, and this will just print out all the values on our terminal. So as we can see, these are all the values of the energy that we recorded during our uh, recording session in the last video. And as we can see, at the given location, we'll have a log file ready, and this putty.log file now consists of all the values that were just printed on the serial terminal. And yeah, so now this is the log file that we will be using for further analysis and visualizing the energy. So since we have the log file stored at our location, we will now use the command prompt to just go to that location. Now we can see our putty.log file is stored in this location. Now, to convert this log file to a trace file, we will be using a log to trace Python file. The log to trace Python file essentially takes a log file as an input, as one of the arguments, and then converts it to a trace file with the same name. So we'll do that. We just run the Python file log to trace and give it the argument as putty.log. Now, as we can see, the sample rate here is 50 Hertz. That means this file basically assumes that the data has been sampled at 50 Hertz, that is at every 0.02 seconds the data has been sampled and the values have been recorded. And now this putty.log file and the Python script run on it has created another file called putty.trace, which is the trace file which we will be using to create a visualization. Now we have another Python file which is the plot from trace file. This is the file that will take the trace file that we just created as an input and then create a plot for our visualization. Now we'll run that and see how our plot looks. And we'll give here the argument as putty.trace. Here we go. So this is the this is the plot of the energy trace that we just recorded using our setup. As we saw, we moved our board around the energy harvester in different patterns. Some of the patterns were in some cases the board was closer to the energy harvester, and in some cases it was away from the energy harvester. So this plot is just plotting the power with respect to time here. And as we move the board around the energy harvester, we recorded these values and converted it into a plot. As we can see, this is the raw waveform, and this has been and by using and by assuming a 50 hertz sample window, this plot has been generated to show us an approximate smooth curve for the raw waveform that we just recorded. Now, the meaning of these peaks is that if our um, P110 P2110B board with our energy energy harvesting record and replay setup is closer to our energy harvester, that means we are getting more energy. That is, if it is if energy can be represented in a square waveform pattern, then it will be on for a longer amount of time. That is, more energy will be supplied by the energy harvester. And that's why we can see that the peaks here, the higher peaks, assume show that the represent the situations where our energy our setup, our replay and record setup was closer to the energy harvest. The smaller peaks just show us that our energy harvester setup was away from the record and replay setup. Uh, so in this way, the energy harvesting record and replay setup records the values. So if the setup is closer to the energy harvester, then we get higher energy, and if it is further away from the setup, then we get lower peaks like these. Now, the in the code, the the power value has been normalized by 10 so that the values don't exceed 10, and that's why our maximum value here can be 10 milliwatts. And yeah, this is how we can use this energy harvesting record and replay setup to record our energy traces so that we can use it for an analysis for the intermittent computation part. So thank you.